In this demonstration, we're going to show a type of mechanical test called the Sharpie impact test. And the Sharpie impact tester has a hammer, and the hammer has certain different weights. In the case of this Sharpie impact tester, it's a 60-pound hammer. And what we do is we break samples at a very fast rate. And what we're looking for is the amount of energy that the sample absorbs before it fails. And so the type of sample is a rectangular piece of metal, and it has a V-shaped notch in it that's called the Sharpie notch. And Sharpie is after the man who invented this test. The Sharpie impact test actually has a very interesting history. It was invented in the late 30s, early 40s, as the United States was getting ready to enter World War II. And one of the problems that the U.S. Navy was facing is that they didn't have a complete understanding of the impact of the heat treatment that the metal would experience as the process of welding took place, and how that welding would have an impact on the mechanical properties. And so the Sharpie impact test was developed as a quick and dirty way to see how tough the metal was. In normal applications, we want our metals to be really tough. In other words, when they fail, it should be a very energy-absorbing, time-consuming, really intense type of experience, as opposed to something shattering like a piece of glass. And so what I'm going to do is show you how this Sharpie impact test works. And the system is very technical. The first thing I have to do is calibrate the 0 point. There, done. So now what I'm going to do is I'm going to load the hammer up. And so at a 60-pound hammer, and if the hammer were to swing and stop, then that means the sample would absorb 60 foot-pounds of energy. But of course it's not going to do that, because that would be a bad thing. So what I'm going to do is I'll load up the hammer, and now I'm going to place a Sharpie impact bar that has been heat treated, so I've maximized its toughness. And I'm going to place that bar here in the direct path of the hammer. And now I'm going to release the hammer, and we'll see how much energy that bar will absorb upon impact. So here we have the result of the ductile sample, and you can see how the surface of the sample looks as though the sample has been ripped. And we see that it absorbed around 28 foot-pounds of energy. So this ductile failure, this ripping of the metal, this is how we want our metals to perform. Now what I'm going to do is I'm going to put a piece of metal in there that's simply been quenched, an oil quench. And so this sample is martensite, so it's the hardest form of steel, but it's also the most brittle form of steel. And so let's load up our sample again. Okay. All right, so this is our brittle form of the metal. Here we have an example of a brittle failure, and you can see how the failure surface looks is nice and flat, like it's almost been cut with a knife. And you notice that it has absorbed a lot less energy. So we're reading around 2 foot-pounds of energy absorbed. This is not how we want our metal to perform. We want the metal to absorb a lot of energy before it actually fails. And this is what the Sharpie impact test gives us, is a way to quickly quantify how much energy a piece of metal is going to absorb. And so what the U.S. Navy did over a 5 or so year period is they went through literally hundreds and thousands of different samples, giving them different heat treatments, putting them into this impact tester, breaking them and saying, okay, that heat treatment would be good, that